Hello everyone, welcome to my new YouTube channel. My name is Rahul and you're watching Fix It Code Academy. So in this video, we are going to discuss about Singleton design pattern, why it is needed, and we are also going to write some pseudocode to understand the same. Okay, so let's get started. So first of all, what is a singleton design pattern and why we need singleton design pattern. So singleton design pattern is needed in those scenario in which we need only one instance of the class uh, to be there in the entire lifetime of the program. I repeat, there should be only one instance of the class throughout the lifetime of the program. So now, like in which scenarios we can need this type of design pattern. Okay, so let's say you have an application, you have developed your own application, and then we definitely need to debug. So wherever it is like we are getting seg fault or anything, we definitely need to debug that. To do the same, we will definitely need some logs. So let's say a function is returning an integer or a function is returning some string, and we want to know whether that particular function is working properly or not. So definitely we have to add some like log statements or some print statement to know the same, whether the program, the code that we have written is working correctly or not. So now to do that, to do that, we have to write a logger class. Okay. So now let's say in this logger class, we write a logger class, and we have some data members and member functions, and let's say there are two threads. Both the threads are creating different objects and trying to log on the same log files. So in that scenario, what happens is, like, you will end up overwriting the same file. Okay, in that way we will not get the right log file as we need. So it may happen that at the same time, the log file which are trying to write, two different threads are writing on that same log file at the same time. So we will end up overriding the same log file. So in this scenario, we will need a singleton design pattern, a singleton design class, in which we will restrict that particular class to not create object and have only one instance throughout the lifetime of the program. In that case, whenever we try to uh, get whenever we try to get the instance of the class, we will have only one instance, the same instance that we created. So in the memory, there will be only one instance of that particular class. So in that case, whenever we have to write to that log file, or we have to write to the log file, or let's say there can be a scenario in which we have to read we have to get the DB configuration, or we have to do some save in our in our application. In that case also, we will need this singleton concept, singleton design pattern concept. So let us write some code to understand the same. So first of all, we have to restrict this particular class to create object. To do that, we can write like this: singleton default. Okay. So let's say if I write private here. Okay. So now let's say if I just write singleton singleton one. Okay. And then I compile. Let's say I just save it here and I compile. Okay. G++, the program that I'm trying to compile is test.cpp. So once I compile, so you see we are getting an error. So this is what we want. Now let's say if I remove this, if I don't have this at all, and then I save it, then in that case, if I compile, so it get compiles. So I can, from this main function, I can create multiple copies of that particular singleton class. And that, in that case, like the whatever issue that I was mentioning, that if we are trying to log write to a same log file at the same time, then we'll end up overriding the same file. So in that scenario, we'll need a singleton class, and we have to restrict that particular singleton class in such a way that we don't create an object outside of that. We have to restrict that in such a way that we don't create object outside of the class. In that means, in main function, we will we have to come up with such a design that we cannot create an object. To do that, that is why I have made the constructor, that is the default constructor, as private, so that we will we cannot create object of this class outside of this class, right? We cannot, we cannot, that we are restricting that, right? So now the next thing is, we have to come up with a function in which we return the instance of this particular class. And each time is we return, it should be the same instance. Like, it should not be a different instance, it has to be the same instance. And in the memory also, there should be only one instance. So let me write a pseudo code from this for the same. Okay. Let's say I call it get instance. Okay. Then get instance. Then I say static um, static singleton instance return instance. Okay. So static singleton instance return instance. So now if you ask why static, because once, so this is like, we call it lazy initialization, meaning first time when this, whenever we call get instance from our program, that is the time when in the memory, this instance memory will be initialized and it will be returned. The next time we call get instance, we will not ending up in creating one more instance of the singleton class. We will return the same instance. So that is why static. And we will also make this static as well, means return type also static as well. Okay. And let's say I singleton, then slice is equal to singleton colon colon get instance. Okay. Now let's have one data member also, because we want to know whether we are having only one instance of that class, or we are having more than one instance of the cat. To know that, we have to have one data member at least. So let's say I will write here int data. Okay. So I will let's say I will have singleton one dot data is equal to, let's say, 60. Okay. And let's print out this std cout. Then uh, let's have let's print this data. Okay, first time because we are doing, right. Let's give an endl. Then now the next thing is, let's have one more get instance. Okay. Then let's assign it. Then first let's check this value, like whatever So this is, we can make it like, let's say 2, singleton 2. Okay, and get instance. And let's say this is singleton 2 dot data, singleton, we need to print singleton 2 dot data. And after that, let's assign, let's say I will assign uh, singleton, singleton 2 dot data is equal to 70. Okay, and then let's print singleton 1 dot data and singleton 2 dot data. Okay, so let's say I will singleton, let's make this singleton 1 dot data, singleton 1 dot data. Similarly, we will make this singleton 2 dot data. Okay, we'll print singleton 2 dot data also. Singleton 2 dot data. Okay, so singleton 2 dot data, std and l. Okay, now we have some pseudocode already written for the singleton class. So let's compile this. Let's compile this. So g++ test.cpp. It's compiled. Let's run the program. Okay, I have not saved it, sorry. So let's compile it again. So it says static singleton. Okay. Okay. So you see, first time when I print, it gives me 60. Next time, I did not initialize the value of singleton 2 dot data. I did not pass, like I did not reassign data singleton 2. So it still gave me 60. That means it returned me the same instance. Okay. And then I made singleton 2 dot data as 70. Okay. And then I again print the value of singleton 1 dot data and singleton 2 dot data. So it gave me, for both the cases, it gave me 70. Okay, that means it's it's returning me one instance only. Means it's means currently whatever our design is, it's holding only one instance. It's not holding more than one instance. If I had not made this private, this as static, means sorry, if this default constructor as private, then I could have like created multiple objects and then initialize data to different like I can make data singleton one as data is 60, then singleton two is 70. In that case we'll get different outputs, but in this case we are having only one instance, and each time we are doing get instance of that particular singleton, we are getting only that instance. Okay, so now let's say there is some problem that can occur even in this code that we have written. So let's say I have singleton, okay, then singleton 3 is equal to singleton 2. Okay, singleton 2, and then what I do, singleton, then I print std cout. Then what I do is, after doing this, I assign singleton 3 dot data is equal to 6, let's say 100. Okay, and then I print singleton 3 dot data, singleton 3 dot data is equal to singleton 3 dot data std and l. Similarly, I want to print singleton 2 dot data. Singleton 2 dot data. 2 dot data. Okay. Now let's save it. Save, Control S, and this let's compile this. Okay, let's see what happens. So you see, singleton 3 dot data is 100, but singleton 2 dot data is 70. That means now there is more than one instance of the singleton class. So we have to and if when we do this like this, the copy constructor of the singleton class is getting called, right? So we have to solve this problem. Now we have to write some code in our singleton class so that this copy constructor, even after that, if we write this code, it will give me some error. Okay, so to do that, we can make the copy constructor of this singleton class as delete, a delete function. So let's say I write here singleton, okay, const and singleton, okay, is equal to delete. Fine. So let me compile this again. So I wrote this particular line, singleton const singleton is equal to delete. Okay, let me compile this. G++. So you see, it's giving me an error now. Declaration of singleton with no type permissions is equal to deref error. So now so let's say if I and compile singleton 3, this thing also, let's say I then compile. Okay, so I have to so still it's giving me huh error here. So it says C++ forbids declaration of singleton with no type of permission, singleton const singleton is equal to delete. So basically I'm trying to delete this particular copy constructor. Okay, copy constructor of this singleton uh, method. So let's say I save it. Okay. So the only problem that there was, I made wrote this is before say writing the singleton class. So now let's say let's run the program. Okay. So now let me do one thing. So I will just open this. Okay. And then save it again. Let's save it again here. Okay. So you see what does the use of deleted function singleton? That means whatever line I wrote here, it is now restricting me to write this particular line. So we don't want to write this line, right? Because by mistakenly also, if the developer is means whoever is writing the piece of code for this class, if he writes this like this, then we'll end up having two instances which will not solve our problem, right? So to solve this program, we will write this particular line of code here in this particular class itself, so that if if let's say from our application, if we write this, if we call the copy constructor, it will throw us a compilation error. So similarly, we have to do it for the assignment operator also. So let's say I will write singleton operator is equal to then const singleton delete. Okay, let's save it and let's now uncomment this one because we want to compile the code. Okay, so now we are holding only one instance of this singleton class. Yeah, so this is all about the singleton design pattern. If you have any cache questions, do let me know, and I will end this video here. And also I have my GitHub link, which I will be leaving in this the description of the video. Do go through this. I will share the pseudocode with you all to go through this video and let me know if any doubt. Thank you.